friends, I am Manas from ARYABHATTA Academy. I hope you are doing well. One famous naturalist and geologist, Darwin, once said that if you are dare to waste 1 hour, you have not discovered the value of life. To know something, to learn something, we have to waste some time. There is no doubt at all. So I hope that to watch this video, you have to spare some time. You have to watch it from beginning to end. Then you will understand the concept, no doubt at all. So I hope that you might have pressed the subscribe button, which can inspire me. So it is time to start the lesson without making any delay. So I have mentioned here resistance and the Ohm's law. My intention to explain about the Ohm's law, but to explain the concept of Ohm's law, I have to take the help of term resistance. So that's why I decided to explain the resistance. Thereafter I shall explain the Ohm's law. See here, this is a conductor. Whenever current is flowing through a conductor, or you can say metallic wire, there is an obstruction to the flow of current, to the flow of electron. That obstruction is called the resistance of the conductor. The obstruction offered to the flow of current is called resistance. Generally we write R for resistance, and its unit is ohm. We can represent it by the omega symbol. Then what is the cause behind the obstruction of a flow of current? See here, children. This is a metallic conductor. In this metallic conductor, large number of free electrons are there. At the same time, equal number of positive ions also there. How the electrons are there? At the same time, equal number of positive ions also there. Which one? Given out by the atoms. And already in the previous video I said that these positive ions are fixed in their positions, what we say lattice space. So in a metallic conductor, equal number of free electrons are positive ions. These free electrons move inside this metallic conductor randomly in any directions as their will and wish. These are the direction they are moving randomly. So when these electrons move randomly, definitely they collide with each other At the same time, they collide with positive ions. Those are present in a fixed position. Now, this metallic conductor, I shall connect it with a cell. See here. This is the metallic conductor. The two ends of the conductor I have connected through a cell and key. That means I maintain a constant potential difference between the two ends of the conductor. I provided one electric field. As a result, electrons start moving from lower potential to higher potential. Lower potential in the sense where there is excess of electrons. Higher potential in the sense where there is deficit of electrons. Due to deficit of electrons, there is higher potential. Due to excess of electrons, there is lower potentials. Once the electric field developed, the electrons present inside this metallic conductor, they start to move from lower potential to higher potential in a specific direction. Before that, they used to travel randomly in their will and wish. Now, they are under the influence of electric force, because there is a electric field, because there is a potential difference, constant potential difference between its ends. So now the electrons starts moving from negative terminal to positive terminals. So whenever the electrons move from negative terminal to positive terminal in a specific direction, they collide themselves, but mostly they collide with the positive charged ions. So whenever they collide, definitely their speed will decrease, their kinetic energy will decrease. They will spare some time, but they can't stay there more time, because there is an electric field. There is a potential difference across its ends, so they can't stay there. Again they get the acceleration. Again they may collide with the other positive ions. That means there will be several collisions during their traveling from negative terminal to positive terminals. That several collisions brings an obstruction to this flow of current, or to this flow of electrons from negative terminal of the conductor to the positive terminal of the conductor. That obstruction is called the resistance, and the substance used for resistance is called the resistor. This is the symbol of resistor. If it is a variable resistor, then I can mention it with the help of a jockey. This is the variable resistor. Later I shall explain regarding that. This is the symbol of a resistor. Okay, the resistance we represent by the symbol R. So I can say that the resistance of a conductor depends upon the number of collisions with the positive ions. If the collisions are more, definitely the resistance also more. If the collisions are less, definitely the resistance also less. So children, I hope that you might have understood what do mean by resistance. Different substances are there. They have different resistance. For example, silver, copper, aluminium, they have different resistance. Among these three, aluminium having more resistance than copper, copper having more resistance than silver. That means silver has least resistance among these three metallic substances what I have mentioned here. So different substances having different resistance, what we will discuss in the next video in details. So without delay, let us move towards the law, that is Ohm's law. One famous scientist said that there is no law except there is no law. So what do you understand? That is up to you. See here, I am going to explain Ohm's law. Children, if two conductors, they are in contact, either directly contact or connected by a suitable conductor, there will be flow of electrons from higher potential to lower potential. For example, this is the higher potential end, this is the lower potential end. Higher potential end means there is deficit of electrons. Or I can show like this way. More electrons are there. Here less electrons are there. Less electrons means I can say it is positive. More electrons means I can say it is negative. So when two metallic conductors either in contact or connected by a suitable wire, there is a flow of electrons from lower potential to higher potential. That means there is flow of current from higher potential to lower potential. That means there is a relationship between the potential difference and the current. This relationship was observed by a famous scientist. His name is George Simon Ohm. It is the matter of 1826. So this observation is stated in the form of a law that is called Ohm's law. What is that Ohm's law? At constant temperature and physical condition, the potential difference across the ends of a conductor is directly proportional to the flow of current. It means if the potential difference double, current also will be double. When the potential difference increases, current also increases. So mathematically I can say that V proportional to I, or I can write that V equal to I R, where R is a constant of proportionality, what is called resistance. If the current is equal to 1 ampere. If there is a unit current, I can say that V equal to R. Since I is equal to 1, I can say that resistance is numerically equal to potential difference across the conductor when the flow of current through it is unit. Or you can say that if 1 ampere of current flow through this conductor, then the resistance of the conductor is equal to potential difference. I equal to 1, V equal to R. So V equal to IR. This is the mathematical expression of Ohm's law. Okay? So this is V equal to I into R, or I can say that I equal to V by R, or I can say that R is equal to V by I. This is one of the famous law in current electricity. Without this law, it is very difficult to understand what is current electricity. So this law is the backbone of the topic. There is no doubt at all. So listen carefully. So V equal to IR, or I can say that R is equal to V by I. If the potential difference is 1 volt, current is 1 ampere. So I can say that resistance is 1 ohm. So 1 ohm is the resistance of a conductor. If there is a flow of 1 ampere of current and the potential difference across its end is 1 volt. When in a conductor, the potential difference is 1 volt. If there is a flow of 1 ampere of current, then the resistance offered by the conductor is 1 ohm. So 1 ohm or ohm is the resistance, or you can say it is the unit of a resistance in SI system. So you can use the kilo ohm, which one is 10 to the power 3 ohm. You can use also mega ohm, 10 to the power 6 ohm. According to the requirement, different cases will use the different units. So one more term I shall say you, that is the reciprocal of resistance 1 by R. This is the reciprocal of resistance. It is called conductance. The unit of resistance is ohm. Unit of conductance 1 by ohm, or we can say that ohm inverse, or you can say that Siemens. Earlier we used to say mho. At present we are not using mho as the unit of reciprocal of resistance. In that place we can use the term Siemens. This is also unit of conductance, or you can say reciprocal of resistance. This Ohm's law, if I express in the form of a graph, I can say that this, if I draw the IV graph, in this graph, x-axis, suppose we will take the voltage or potential difference, and y-axis we will take the current. So definitely you will find a graph which is straight. It means the potential difference is directly proportional to current flowing through it. If I take the slope of this graph, that means delta I by delta V, what it will give? Can you say? It gives reciprocal of the resistance. It gives reciprocal of the resistance. Okay? But there is a limitation of Ohm's law. What is that limitation? I mentioned in the law. At constant physical conditions, means the dimensions, the materials, as well as the temperature should be constant. For metallic conductor, definitely we find the graph where the graph is a straight line. That means the potential difference is directly proportional to current. Let us verify the Ohm's law by the help of an experiment. That means experimental verification of Ohm's law. Experimental verification of Ohm's law. Children, don't forget to share this video with your friends. As a result, they can get the chance to learn. Let us come to the topic. This is the battery. This is the rheostat. This is a standard resistor, unknown resistance. So this is key, this is the ammeter. Everything is here connected in series. Everything is connected in series. You should take care that the negative terminal of the ammeter should be connected to the negative terminal and positive terminal should connect with the positive terminal of the cell. So already you know that current flows from higher potential to lower potential. This is the way current flow, but this is the way electrons move. According to conventional direction of current, its direction always opposite to the direction of a flow of electrons. This is the rheostat. Rheostat is a variable resistor. Its resistance can vary. Why I am taking a resistance? Because with the help of adjustment of this resistor, I can allow different amount of current according to the requirement within certain limit. So variable resistor means here there is a jockey, or you can say this is a slider. By moving it from here to here, I can change the resistance. Suppose the jockey I shall put here. The length of the resistor will increase. resistance will increase, current will decrease. If I move it to left side, the length of the resistor will decrease, current will increase. So the rheostat, it is a variable resistor. By adjusting the slider of the jockey here, I can allow the different amount of current that is within a limit, within the capacity of this rheostat. This is the battery, this is a standard resistor, this is the key, this is the ammeter to record or to measure the current. Now we start the experiment. Now switch is here, suppose I made it on, already it is on. So the switch is on, there will be a flow of current. Okay, one thing I have forgotten, I have to connect a voltmeter across this unknown resistor. All the time the voltmeter connected in series, voltmeter connected in parallel. I have connected both its ends across the resistor. This is the parallel connection of the voltmeter. Ammeter is connected in series, whereas the voltmeter is connected in parallel. So listen carefully. Now suppose the switch is on, there will be flow of current. So we can record the current from the ammeter, whereas the potential difference from the voltmeter. Suppose this is the current, this is the voltage or potential difference. At the beginning, you adjust the slider, adjust the jockey, however it will allow minimum amount of current. Then you record the current from the ammeter, voltage from the voltmeter. For example, here current is 2 ampere, potential difference is 4 volt. Current in ampere, potential difference is. Now again readjust the slider. You can decrease the length of the resistor. That means you can allow more amount of current to flow through it. Suppose the current is 4 ampere, voltage you observe that is the 8 volt. This is rough, just an example I have given. There will be little variation, no doubt at all. Similarly, again if you readjust the jockey, you change the length of the resistor. You bring it towards left. That means the length of the resistors will decrease here. Flow of current will be more. For example, now you got the 5 ampere of current. You are getting the voltage is 10 volt. So this last column, ratio between voltage to the current I have mentioned. So 4 by 2 I got, that is the 2. 8 by 4 I got, that is 2. 10 by 5 I got, that is 2. That means I found that V by I is constant. So I said that Ohm's law, V equal to IR, or V is equal V by I is constant. This is the verification of Ohm's law. This is very simple law, but it is one of the important law in the topic current electricity. Now, by taking these readings, if I draw a VI graph, before that I said IV graph, now I am telling VI graph. How the graph will be? So this is the x-axis, this is the y-axis. Suppose I shall take the I is in the x-axis, V is in the y-axis. This will be the graph. For example, you see that this is the point A, this is point B. This is point O, C, D, I gave P name, Q. This one represents delta V, this one represents delta I. This is VI graph I have mentioned here. If I take the slope of this graph, definitely I can say that potential difference between A and B, higher potential, lower potential, current difference at the point C, at the point D, I can say it is delta V by delta I. Which one is constant? So, from the slope of VI graph, I found resistance. From IV graph, I explained we got reciprocal of the resistance. From VI graph, we got resistance. So, it also verified the Ohm's law graphically. So, I hope that you might have understood the concept very clearly. So, in the next video, I shall explain more about the factors affecting the resistance and some graphical representation also. So, I hope you might have understood, and don't forget to share this video to your friends. Thank you. Jai Hind.